The next step in our lesson is finding the area of a triangle. And the area of a triangle has a slightly different formula. The formula is area equals base times height, but then you divide it by 2. And the reason that we do this is when we do the base times the height, if I were to show you a rectangle, the base times the height would give me the area of this entire rectangle or square. In this case, it's a rectangle. Okay. I don't want the area of that whole square, but a triangle cuts it in half. So if I divide it by 2, then I get rid of this half and I just have the area of that triangle. So again, I'll start out by finding the area of the parallelogram or the rectangle, base times height, but then I have to divide it by 2. And that's the big thing that people will always forget with triangles. You really have to divide it by 2, otherwise you're finding the whole area of the rectangle or the parallelogram. So here is my first triangle here. I'm going to plug it into the formula. I would use this as my base and this is my height. If you flip-flopped them, that is fine. So I'm going to say that my base is 6 times my height is 5, and then I need to remember to divide it by 2. So when I go solve it, I would do 6 times 5 is 30, and 30 divided by 2 would give me an area of 15 centimeters squared. Okay, so that would be the area for this triangle here. If I'm on the next example over here, I am doing the same formula, area equals base times height, and then I'm going to divide it by 2. So my base and my height, just like at the parallelograms, I'm looking for this giveaway, this right angle here. My base could be 11, my height could be 6. So I'm plugging in 11 times 6, and then I'm dividing it by 2 so that I don't find the area of the entire rectangle. So 11 times 6 is 66. So the area of this whole rectangle is 66. I want to then cut it in half. That would give me an area of 33 meters squared. Is just this section here. Right? I don't want that part, so I divided it by 2. Now let's do a couple more examples. These are not right triangles like the first 2 examples. They're both acute triangles, right? They have 3 acute angles inside them. So cute. I use the same formula for all triangles, base times height, and then I divide it by 2 because it's half of whatever square, right, that it would be a rectangle, even if it's an acute triangle. Okay, my base, however, is going to be the whole bottom of my triangle. Okay, so if this section is 3 and this section is 4, my whole base, I would add them together. The base of this triangle is 7. Okay, and then the height is from the base all the way up to the tip of the triangle. Okay, again, I'm looking for that right angle. So my height would be 1.5. Okay, so I have my height and I have my base. So when I plug it into my formula, my base is now 7 because I added the 2 bases together, times 1.5. And then I need to remember to divide it by 2. So I'm going to plug this into my calculator. And I end up 7 times 1.5 gives me 10 and 5/10. Divided by 2 gives me 5 and 25/100. And I can put my inches, my square inches on there. Okay, it doesn't always come out perfectly. Sometimes there's a decimal answer. Okay, and then my other example over here, I have another acute triangle. I need to find my base and my height. Now, it doesn't have the right angle, but you can put it in there if you wanted to. Okay, so I need to add my 2 bases together to get the entire base of this triangle. So I would do 12 plus 6, which would give me a base of 18. And then my height would be 5.5. So when I'm going to plug in my formula, base times height divided by 2, I'm going to do 18 times 5.5. And then I need to make sure I divide it by 2. That gives me, when I do it in my calculator, I get 99 divided by 2. Gives me an area of 49 and a half. That's feet